Okay, so in chemistry, we potentially have a lot to learn. There's about 120 elements, just shy of that. And if we were to know everything about every one of those, it would take forever to learn. Luckily, what we do have is an organization in our periodic table that allows us to just learn about a few elements and then infer or have an educated guess about the ones that are neighboring it or nearby to those elements. So rather than getting you to learn all 30 of these and everything about them, what I'm going to suggest is you learn about 10 of them and then apply that learning to what you see happening to the ones that are under them or next to them in the periodic table. So the groups or the families, the columns, these are called groups or families, all have very, very similar properties. We've just seen a video, and it is a little bit made up, but we've seen a video that shows that when we go from lithium to sodium to potassium to rubidium to cesium, the reactions with water get more and more violent, more and more explosive. And that's because they all have one electron in their outer shell. So they react really easily with things. They're highly reactive. As you go further down, the atoms are getting bigger and bigger and bigger. So that electron is further away from the nucleus. It's not held on as well. And so it loses that electron a lot more easily. So we can actually make predictions. If we knew the electron configuration of lithium, we could actually guess what it is for sodium, guess what it is for potassium, and so on. So the structure of the periodic table allows us to do less rote learning and more applying our knowledge. So the groups or families are the columns, so up and down. So they go up and down a periodic table, they're called columns. So they go down like this. So we've got what's called the alkali metals, the earth metals, and so on. The halogens over here are some pretty nasty chemicals like chlorine and fluorine. They're often used for antiseptics, things like iodine and bromine to clean cuts out. So those ones there have all got really similar chemical properties and very similar uses. So over here we have fluorine, which is really nasty stuff, not to be confused with fluoride, which is not nasty. But it is good for the health of our teeth. Under it, we've got chlorine. Under that, you've got bromine. And under that, you've got iodine. So these are the halogens, another one of our families, really similar properties and chemical reactions. Here we've got helium, neon, argon. They're probably the three you need to know. And we know that these ones don't react with anything. So again, they're in the same family. So they have similar chemical properties. And the reason for that is, and we're going to get to this with atomic structure shortly, the reason for this is that they all have the same number of valence or outside electrons. So really, I only need to learn about hydrogen because it's a special one, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon, and I probably have enough knowledge of atomic structure and chemical properties to explain how all the rest of these that are underneath them react and behave and why they're used for what they're used for. So it means instead of learning about 30 elements, you can kind of get away with learning about 8 to 10 of them and then apply that knowledge to the rest of them. And that's what we're going to be looking at, hopefully applying soon. The other thing that exists in a periodic table are the periods. So they go across. So if you think of those are the periods in a day, the first one's got 2 elements in that, 2 periods, 2 elements in that period, that sort of thing. So the periods are going across. And there's one here with hydrogen and helium. There's the second period, the third period, the fourth, the fifth, the sixth. And we've discovered a seventh, We don't know if it goes any further than that, so they are the periods. All that the periods have in common is the number of electron shells around their atom. That's all they have in common. They also go from being metal to non-metal, so we see a trend. So we have a trend in their state, we see trends in their bonding, trends in their properties. So that is our rows which go across. We see trends, so it goes from solid to gas often. It goes from being metal to non-metal. And as I say, the reason for this is that they all have their outermost electrons, their valence electrons, are on the same shell. So in the first energy level, both hydrogen and helium, the first period, hydrogen and helium both have their valence electrons in the first shell. Lithium, beryllium, boron, carbon, all the way up to neon, all of them have their valence or outside electrons in the second shell, hence the second period. Sodium and all of them have their outermost electrons or valence electrons in the third shell. So if we know, for example, about sodium, we should be able to know we should know about how many electron shells everything in its period has. But we should also know everything about the chemical reactions and number of valence electrons from its group. That's how we use a periodic table to save us having to learn and remember lots and lots of stuff.